alaikum wa rahmatullahi wa barakatuh. Hi everyone, nice to meet you all. Today, inshallah, we will start together to complete in Cambridge International AS and A level chemistry paper multiple choice, paper number 9701 by 12 May June 2019. If you want to see any question from questions 1 up to question 20, you can find the link of the videos down in the description box. Now we will start from question 21 up to question 40. At first we will start with question 21. Compound X doesn't show cis and trans isomerism. What could be the identity of compound X? At first you must know that cis and trans isomerism. To find it, we are looking for alkenes. We are looking for compounds containing C double bond C, because in the case of alkenes, double bond contains two carbon atoms restricted in their position. So if we start to make any rotation in the compound, we will have new compounds. But in the case of single compounds, we have free rotation in the single covalent bond. According to the free rotation, we don't have any cis and trans isomerism in single covalent compounds. But in the case of double covalent compounds, we have restricted carbon atoms. The restricted carbon atoms, if we start to have any change in the position of bulk groups, any change in the position of substitution, we will have new isomers. So we will start to draw the structure of our isomers. At first, 1,1,2 trichloropropene. 1,1,2 trichloropropene, we have two chlorine atoms on the same carbon atom. And on the other carbon atom, we have one chlorine and one methyl. So we will start to see our compound. If we start to rotate any chlorine atom from its position, of course we will have the same compound. So in our compound 1,1,2 trichloropropene, we don't have any cis and trans isomerism. In the case of the second compound 1,2,3 trichloropropene, we have trans and cis isomerism because we have two chlorine atoms and one hydrogen atom, one methyl chlorine. So when we have two chlorine atoms opposite to each other, we can say we have trans isomerism. When we have two chlorine atoms in front of each other, we have cis isomerism. So in the case of choice P, we can see in 1, 2, and 3 trichloropropene, we have cis and trans isomerism. In the third choice, 1-chloropute-1-ene, 1-chloropute-1-ene, we can see we have hydrogen, hydrogen, chlorine, and one ethyl group CH2CH3. So we have trans isomerism. And if we start to rotate the compound and put the hydrogen atoms in front of each other, we will have cis isomer. So in the case of third choice, we have cis and trans isomerism. The last choice, we have two carbon atoms attached by double bond, and we have hydrogen and hydrogen, one methyl CH3 and one CH2Cl. So we have two hydrogen atoms form cis isomer, and if we start to change the position of hydrogen and methyl group, we will have the trans isomerism. So of course we have cis trans isomerism in the last choice. So our correct answer is 1,1,2 trichloropropene. Question number 22. The diagram shows the repeat unit of an addition polymer. In the case of addition polymer, we have our monomer made of alkenes. So in our monomers, we have two carbon atoms attached to each other by double covalent bond. What is the correct name of the monomer that would form the polymer. At first, we are looking for compound name, and our compound name it is alkene. So our functional group is alkene. Then we are looking for the longest continuous carbon chain. 1, 2, 3, 4, 5, 6. If we start to change, we will have 1, 2, 3, 4. So it is short carbon chain. As we are looking for the longest carbon chain, we will take C2H5C, C, C2H5. So we have Higgs double bond in position 3. So we have Higgs 3E. Don't forget we have two guests. We have two substitutions on the two carbon atoms in position 3 and position 4. So we have 3 and 4 dimethyl Higgs 3E. It is trans isomerism. So our structure is trans 3,4 dimethyl Higgs 3E. Next question number 23. A molecule of granule is shown. What is formed when granule is reacted with an excess of cold dilute acidified potassium permanganate ions? At first, we have two choices for making acidification or oxidation by using acidified potassium permanganate. The first one by using cold dilute potassium permanganate, and in this case we will break a double bond and add two hydroxyl group, add two alcoholic groups, two OH groups. The second choice is to break double bond and add highly concentrated acidified hot potassium permanganate. In this case, we will break a double bond and CH2 group will convert it into carbon dioxide groups, CO2 group. And if we have secondary carbon atom, it will form aldehyde. If we have tertiary carbon atom, it will form ketone. So we have propanone plus carbon dioxide plus water. Question number 20. So we have propanone plus carbon dioxide plus water. If we come back to our question, so just we will break double bonds in our compound and start to form new and add new alcoholic group. So add OH, 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 OH. So the correct answer will be A. But if we start to make oxidation by using hot concentrated acidified potassium permanganate, we will have the correct choice is C. Because we will break the double bond, each secondary carbon atom will be converted into aldehyde and each tertiary carbon atom will convert it into ketone and each primary carbon atom will convert it into carbon dioxide. So the correct answer will be C. Okay? Question number 24. Alcohol W can't be made by reducing carboxylic acid. Alcohol can't be made by reducing a carboxylic acid. Okay. Alcohol W gives only one product when dehydrated with concentrated sulfuric acid. What could be the identifier of W? Okay, if we reduce the carboxylic acid reduction will form at first aldehyde and then will form our primary alcohol. And our alcohol cannot be made by reducing carboxylic acid. So, of course, we should cancel all primary alcohols. So, it isn't primary alcohol, it is secondary or tertiary alcohol. So, we will start to see our choices. At first, butane 1-ol. Butane 1-ol, it is primary alcohol, cancelled. Second one, butane 2-ol. It is secondary alcohol with us. Third one, propan 1-ol. It is primary alcohol, cancelled. Propan 2-ol, it is secondary alcohol. So we have two secondary alcohols, butane 2-ol and propan 2-ol. Which one of them will be dehydrated with concentrated sulfuric acid and give only one product? So we want to speak about dehydration. In the case of dehydration by using sulfuric acid, we will remove one molecule of water. So in the first one, ethanol, when we remove one molecule of water, we will have ethene plus water. In the second one, when we remove one molecule of water, we will just have propene, methyl propene. Just we start to remove one molecule of water from methyl propene. So we will have methyl propene plus water. In the third choice, but2ene. When we start to remove one molecule of water, we have two choices. The first choice to remove HOH between circle. So we have CH2 double bond CH, CH2, CH3. Its name is butene. Second choice to remove OHH. When we remove OHH, we will have CH3, CH double bond, CH, CH3. We have but2ene. We will have but2ene, so we are talking about two different products. So when we start to make dehydration for but2ene, it will produce two different products. So when we start to come back, of course, the alcohol which will produce only one product is propan 2-ol. It is the correct answer. Next question, question number 25. Which product can be made from bromoethane by elimination reaction? Elimination reaction, condensation reaction, it is one type of reaction in which we start to remove small molecules. For example, we can remove one molecule of water, we can remove one molecule of HCl, one molecule of HBr. In our reaction, we will remove one molecule of HBr. So just we will remove HBr and form a double bond. So we have CH2 double bond, CH2, we have ethene plus potassium bromide plus water. Next question, question number 26. Propene, bromine and hydrogen bromide are mixed in the dark. A number of products are formed, some in very small quantities, so we are accept even our minor or small quantity of isomer. Which substance won't be present in the mixture of the product? We have 1 bromopropan, 2 bromopropan, 1,1-dibromopropane and 1 and 2-dibromopropane. At first we have propene and we will start to add hydrogen bromide. By adding hydrogen bromide, according to Markovnikov rule, Markovnikov rule says that the hydrogen atom will be added to the carbon atom has the highest number of hydrogen atoms. So we have CH3, CHBr, CH3. So our major product according to Markovnikov rule, CH3, CHBr, CH3. It is the major product. Second product, CH3, CH2, CH2Br. It is the minor product. It is product in a small quantity because it is not preferred according to the stability of the carbon atoms. Stability of the carbon atoms in your compound. Stability of carbon cation. Okay, so it is the two isomers will be formed. The two products will be formed. Second one, propene plus adding Br2 Just we will break a double bond and add Br. So we have CH2Br, single bond C, CH3, CHBr. So we will have 1 and 2 dibromopropane. 1 and 2 dibromopropane. So we have 3 main products. We have the first one is 2-bromopropane. We have 1-bromopropane and we have 1 and 2 dibromopropane. So the third choice 1 and 1 dibromopropane is not accepted because we have 2 bromine atoms on the same carbon atom, and this choice won't happen in any additional reaction. It is accepted in substitution reaction only. Next question, question number 27. Which reagent could be used to distinguish between ethanol and propanol? At first, ethanol and propanol are aldehydes. We have only one reaction that can differentiate between ethanol and propanol. In this reaction, it is one of identification reaction for ketones, but it can react only with one aldehyde, ethanol. So, in the case of making iodoform reaction, by reacting ethanol plus iodine, we will have yellow precipitate compound. But in the case of propanol, we will have no reaction. It is iodoform reaction. We will start to add sodium hydroxide and iodine and make warming. We will have CHI3. It is solid yellow precipitate and used for identification of ethanol and ketones only. But all other aldehydes give negative results. Next question. Question number 28. The diagram shows that a carboxylic acid P may be formed from X, Y, and Z. Okay, so we have alcohol is oxidized to form carboxylic acid. Aldehyde oxidized to form carboxylic acid. Nitrile also oxidized to form carboxylic acid. Which row is correct? Alcohol X is primary or secondary? Of course, as we have aldehyde from oxidation, of course we have primary alcohol. The change in relative molecular mass is greatest for. I calculated the relative molecular mass for each one. Alcohol OH group is 17, nitrile NH2 is 16, aldehydic group is 29 CHO, and carboxylic acid group is 45. Of course, the largest increase from nitrile to carboxylic acid. So the correct answer from Z to P. Down we can see different reaction for identifications oxidation of primary alcohol. When we make oxidation of primary alcohol, we will have aldehydes plus water. And when we start to make oxidation for secondary alcohol, we will have ketone plus water. And when we start to make oxidation for tertiary alcohol, we will have no reaction. So in our question, of course, we will take primary alcohol as it will form aldehyde, and aldehyde oxidation will form carboxylic acid. Down we can see the nitrile compounds reaction and oxidation reaction. It will form the corresponding carboxylic acid. Propanonitrile will form propanoic acid, CH3, CH2, C double bond O, OH. It is propanoic acid. Question number 29. One molecule of compound R, CH3, CH2, CH2, O, C double bond OH. Take care. Your compound is ester. What is the name of compound R? How does its boiling point compare with its butanoic acid? Okay, at first we know that any ester is formed from the reaction between carboxylic acid and alcohol. And we start to remove one molecule of water in condensation or elimination reaction. In our reaction, we must know which part comes from alcohol and which part comes from carboxylic acid. So we can see our functional group of carboxylic acid group is HC double bond OO. So we have methanoic acid reacted with propanol. Meth, eth, prop. So we have propyl methanoate. And the boiling point of carboxylic acid, of course, is higher than the boiling point of ester, because each one of carboxylic acid can form at least 2 hydrogen covalent bonds. As we have 2 hydrogen intermolecular force of attraction, so all carboxylic acid boiling point are high. So our choice is propyl methanoate, and it is lower than butanoic acid. In our table, we can say some relationship between the boiling point of different compounds from different families, like alkane, ether, ester, aldehyde, ketone, alcohol, and carboxylic acid. Of course, you will find that the highest compounds in boiling point is carboxylic acid. Its boiling point is 113. Then we can find esters. Esters' boiling point is 32. So we are comparing between different compounds related to their intermolecular covalent bonds or intermolecular force of attraction. At first, in carboxylic acid, we have hydrogen bond. In the case of ester, we have moderate dipole. And the other compounds will be less in the boiling point. Next question. The diagram shows the infrared spectrum for compounds. Which compound could be Q? At first, I will start to tell you some information about infrared to differentiate between different compounds, like alcohols, carboxylic acids, like aldehydes and ketones. At first, in the case of alcohols, you will find we have band. This band more than 2000, and it is quite broad, not highly broad band. In the case of aldehyde and ketones, we have carbonyl group. Carbonyl C double bond O stretch group. Its band is between 1500 up to 1700. Okay, and this band is 4 and specific for carbonyl group, even in aldehydes or in ketones. Of course, in carboxylic acids also we have carbonyl group, so we will find C double bond O in the same region. But take care, in the case of carboxylic acid, we will have very broad band for OH group, OH stretch, very broad band, more than 2000. So the aldehyde or ketones, we can identify from them, and we need just to identify between aldehydes and ketones. In the case of aldehydes and ketones, we can differentiate between them from bands between 1700. How? At first, for aldehydes and ketones, we will have carbonyl group, and we have carbonyl group for both of them at 1700. And in the case of aldehydes and ketones, we have different peaks more than 2000. The peak for ketone is just in this shape. And in the case of aldehydes, we have different shape. We have different peaks identified for the aldehydic group. So if we start to see compound with the same fingerprint and we have identified peak in region 1700, we are talking about aldehyde. If we can find one peak in region 1700 and one peak in the same shape, we are talking about ketone. So when we start to come back to our compound, at first we have carbonyl group between 1500 and 2000. So we have carbonyl group. We have one peak, but this peak is not broad peak. So as we don't have broad peak, we don't have OH group. We don't have alcohol. And also we don't have very broad peak for carboxylic acid. So we want to identify just if it is ketone or if it is aldehyde. If it is aldehyde, we will find extra fingerprints, extra bands in this region. But as it is ketone, we won't find all of these fingerprints. So we have butanone, not butanol, as we don't have broad band of alcohol. Not butanoic acid, because we don't have the broad band of carboxylic acid. Not butanal, because we don't have fingerprint of aldehydes. It's okay? Now we will start in section B. Take care in section B questions. It is type of new questions different from your IGCSE questions. In this type of questions, we have 3 or 4 choices. We have 3 choices. We will start to write A or B or C or D. A means that you can know that 1 and 2 and 3 are correct. B means 1 and 2 only are correct. C, 2 and 3 only are correct. D, 1 only is correct. So we will start to answer the following question by using the same rules. At first, when oxygen O2 reacts with hydrogen sulfide, the products are SO2, sulfur dioxide, and water. Mixture Y contains an equal number of 2 molecules shown, and no other molecules. The first molecule is O2, O double bond O. But our oxygen molecule contains 2 isotopes. One of them is O816, the other one is O818. Hydrogen sulfide H2S, we have sulfur atoms surrounded by 2 hydrogen atoms. Sulfur is 1632, each hydrogen atoms is each 1. Which statement about Y is correct? The average relative molecular mass in Y is 34. Of course, we will calculate the average relative molecular mass for oxygen, so we have 16 plus 18 equals 34. And the average relative molecular mass for hydrogen sulfide, it is 32 plus 1, we have 34. If some molecules are removed from Y, the average relative molecular mass of the mixture remains the same. Of course, if we start oxygen, remove, we will have H2S, hydrogen sulfide. Its relative molecular mass is 32 plus 2, so we have 34, so it is the same. So the first choice is correct. Average MR is 34. Second choice is correct. Third choice, when mixture Y is ignited, some hydrogen sulfide remains unreacted. Of course, it is correct because in burning reaction, we just use oxygen for completing the burning reaction. Hydrogen sulfide won't include it in the reaction, so we still have hydrogen sulfide. So we can say that 1, 2, and 3, all of them are correct. As 1, 2, and 3 are correct, so our best choice is A. Question number 32. Which statement about an atom Tc99 are correct? At first, we are talking about technetium. Technetium is one of element. Its structure is Tc4398. It has 13 fewer protons than neutrons. It is the first choice. Just we want to calculate number of protons is 34. Number of neutrons equal atomic mass minus the atomic number equal 98 minus 43 equal 55. So we can see that the difference between number of neutrons and number of protons nearly 13, not exactly. It forms Tc plus 299, which has 45 electrons. Plus 2 means we have positive ion. Positive ions means our atom will lose 2 electrons, not accept 2 electrons. So its number of electrons will decrease by 2 electrons. And its number of electrons will be 41, not 45. Number 3, it has 56 nucleons. 56 nucleons, it is wrong, as nucleons, it is number of protons plus number of neutrons. And of course, in our element, we have 98 nucleons. So 3 is wrong, 2 is wrong, and the correct answer is 1. Question number 33. In which reaction are nitrogen atoms reduced? At first, reduction reaction means removing oxygen, means adding hydrogen, means reduction is the change in oxidation state. We can say reduction is gaining electrons and it is the decrease in the oxidation state. At first we have NO2 converted into N2 plus O2. So nitrogen converted from nitrogen oxide into nitrogen. So we lose oxygen. So it is reduced. Second one, NO2 converted into N2O. So the number of oxygen atom decreased. As the number of oxygen atom decreased, we are losing oxygen. So we have reduction reaction. NO2 plus water will form NH3. Of course, we lose oxygen. So we are talking about reduction reaction. So 1 is correct, 2 is correct, 3 is correct. Correct choice is A. Oxidation is gaining oxygen and reduction is gaining hydrogen or losing oxygen. Okay? Question number 34. The manufacture of ammonia from nitrogen and hydrogen is an important industrial process. Which of the following would leave the equilibrium constant Kp for the formation of ammonia unchanged? At first, take care the equilibrium constant is not changed by changing the conditions or the concentration of reaction. So when we start to add catalyst, the rate of forward reaction will increase and the rate of backward reaction will increase, and we will have no change in concentration of reactants or concentration of products. Adding ammonia. By adding ammonia, the reaction will change its equilibrium position to cancel your effect or to opposite your effect. So our equilibrium constant won't be changed. An increase in pressure, of course, the same. We are talking about equilibrium constant. Equilibrium constant is stable, not changed. In the reaction A plus P will form Cc plus Dd. Equilibrium constant equal partial pressure of product C raised to the power number of moles of C. Partial pressure of D raised to the power of number of moles of D, divided by partial pressure of reactants A raised to the power of number of moles of A, and partial pressure of P raised to the power of number of moles of P. Pa is the partial pressure of A in equilibrium constant, of any substance in equilibrium constant, and A, the power, it is the number of moles of your molecule. If you change any condition, equilibrium constant will stay the same. Question number 35. Which reaction involving calcium and its compounds produce two gaseous products? Heating solid anhydrous calcium nitrate. Heating calcium nitrate will produce calcium oxide, nitrogen dioxide, and oxygen. So we have two gases. Heating solid anhydrous calcium carbonate. Heating calcium carbonate will produce calcium oxide and carbon dioxide. Adding calcium metal to water, we will form calcium hydroxide plus hydrogen gas. So only the first equation will produce two gaseous products. Question and answer 2 and answer 3 is not correct. So our correct choice is D. Question number 35. A small quantity of hot concentrated sulfuric acid is added separately to solid samples of potassium halide, Kx. Which potassium halides reacts to produce a mixture of products that include our halogen? This question we studied it in halogen chapter for identification and knowing the strength of hydrogen halides. Which hydrogen halide will be stronger than the other hydrogen halide? So we will start to compare between chloride, bromide, and iodide. We are reacting them with a strong oxidizing agent like sulfuric acid. The bond between H and chlorine in hydrogen chloride compound is very strong. So when we start to react it with sulfuric acid, we will have HCl plus NaHSO4. In the case of hydrogen bromide, we will have acid-base reaction but in two steps reaction. In the first step, we will have hydrogen bromide and NaHSO4. In the second step, we will have bromide gas, so we will have brown fumes, sulfur dioxide, colorless gases, plus water. So observation with hydrogen chloride is steamy fumes. With bromide steamy fumes, then we have brown fumes from bromide gas. With iodide, we have steamy fumes, bubble fumes, and then we will have purple fumes. Purple fumes of iodine in three steps because sulfuric acid is very strong oxidizing agent and iodide is weak. So its compound will react in different steps. We can write four equations. H2SO4 plus NaI will form Hi plus NaHSO4. Sulfuric acid plus hydrogen plus iodine will form iodine purple fumes and sulfur dioxide and water. And with excess, we will have excess of iodine plus sulfur, and then we have hydrogen sulfide. So we can say the reaction at first we will have the hydrogen halide. If we have excess, we will have halogen plus sulfur dioxide. If we have excess, we will have halogen plus sulfur. If we have excess, we will have hydrogen. We will have halogen plus the hydrogen sulfide gas. So our correct answer is potassium iodide will form iodine and potassium bromide will form bromine. Question number 37. The diagram shows a compound used as a flame retardant. Which statement about this structure are correct? The empirical formula. At first, in the empirical formula, just start to convert your compound from skeletal formula into structural formula and start to count number of carbon atoms, number of hydrogen atoms, and number of bromine atoms. For example, this carbon atom is CH2, this is CH, CH, CH2, CH2, CH, CH, CH2, CH2, CH, CH, CH2, CH2. So we are talking about C12, H18, PR6. Empirical formula, it is the simplest molecular formula indicating the ratio of each atom. So just divide by 6, we have C2H3PR. It is our compound. Then, the C12 ring is not planar. The C12 ring is not planar. We want to know if our compound is planar or not planar. To know if the compound is planar or not planar, the molecule will be not planar if we have sp3 hybridization. sp3 hybridization carbon atom means we have non-planar compound. In our compound, we have all carbon atom is attached with different atoms, is attached with different 4 atoms. So we have sp3 hybridization. So sp3 hybridization are make compounds non-planar compounds. So of course our ring is not planar. There are 6 chiral carbon atoms. If we want to research for chiral carbon atoms in the compounds, we are researching for carbon atom attached with 4 different compounds. So 4 different groups. So we are looking for the carbon atoms which can form 3 bonds. So we have 1, 2, 3, 4, 5, 6. 6 carbon atoms are chiral carbon atoms. So it is the correct answer. Question number 38. Halogenoalkane can be hydrolyzed using aqueous sodium hydroxide. Which compound tend to be hydrolyzed by an SN1 mechanism? SN1 mechanism is characteristic for tertiary compounds. So we are looking for tertiary halogenoalkane. So at first, which one of these compounds is tertiary halogenoalkane? You can see that we have the first compound is tertiary carbon atom attached with the other substitution. So we have tertiary carbon atom. In 2, we have also tertiary carbon atom. We have carbon atom with no hydrogen. But in the third choice, we have secondary carbon atom. So the third halide is wrong. Okay. Question number 39. In an organic synthesis, a 62 yield of product is achieved. Which conversions are consistent with this formation? We have 74 grams of butane to all formed and converted into 44.64 grams of butanone, 74 grams of butane 1-ol converted into 54.56 grams of butanoic acid, 74 grams of 2-methylpropane 1-ol converted into 54.56 grams of 2-methylpropanoic acid. At first, we have many isomers, like butane 2-ol, butane 1-ol, 2-methylpropanol. All of these are isomers. Butanoic acid and 2-methylpropanoic acid are isomers. So, if we want to calculate the relative molecular mass of the compound, we must know that all the isomers have the same relative molecular mass for saving time. So, at first we will calculate the relative molecular mass of butanol. MR of butanol is 74. Our yield equal actual yield divided by theoretical yield times 100. So, just by calculating 44.64 divided by accepted yield for butanone, we can calculate it by calculating the number of moles of butanone should be formed is 1 mole. Relative molecular mass of butanone is 72. So 44.64 divided by 72 times 100 equals 62. So it is correct. Second choice is the same, just we know that the relative molecular mass of butanol is 74. So 74 grams of butanol is 1 mole of butanol. Our product must be 1 mole. Just we calculate yield equal mass over relative molecular mass equal actual yield over theoretical yield times 100. So we have 54.56 divided by 88 times 100. So we have 62. And the same in the last one. So we have 62. So our correct answer is 1, 2, and 3. It is the correct answer. We have butane 1-ol, butane 2-ol, methylpropane 2-ol are all isomers. We have primary alcohol, secondary alcohol, and tertiary alcohol. In the second one, butanoic acid and 2-methylpropanoic acid, we have also 2 isomers. So just we want to calculate the relative molecular mass for the isomers one time, not more than. An oxidizing agent that can oxidize ethanol to ethanoic acid or ethanoate ion will also oxidize methanoic acid to carbon dioxide and water. Which reagents on heating will react differently with methanoic acid and with ethanoic acid? At first, we want to know that the reaction between sodium carbonate and ethanoic acid will produce sodium ethanoate water plus carbon dioxide. And we have the methanoic acid plus sodium carbonate will form the sodium formate or sodium methanoate plus water plus carbon dioxide. Ethanoic acid is not oxidizing by filling solution to form red precipitate. Formic acid or methanoic acid have properties of aldehydes, so it can react with filling reagent to form red precipitate. And we can see in the following reaction, ethanoic acid was acidified with potassium permanganate. We have no reaction. But in the case of methanoic acid, oxidation will form the formaldehyde plus water. So it is the oxidation reaction by using different types of reactants. We can see that in the case of adding sodium bicarbonate will react with methanoic and ethanoic acid. By adding filling reagent will react with methanoic and won't react with ethanoic. And dilute acidified potassium permanganate, it will react with methanoic only and won't react with ethanoic. So of course we can identify between them by using filling reagent and dilute acidified potassium permanganate. So we take C choice. Thanks for your watching. I hope that you understand our paper 9701 by 12 multiple choice for May-June 2019, and I hope to have share and comment from you. If you want to ask any question about our paper, don't be shy to send your question. Thanks for your watching and see you soon. Assalamu alaikum wa rahmatullahi wa barakatuh.